On August 10, 2020, an atmospheric titan awakened over the American Midwest. It was not a tornado with its familiar twisting funnel. This was something different. A solid wall of wind, 100 miles wide, began a relentless 770-mile journey across the continent. For 14 hours, it moved with the speed of a freight train, flattening everything in its path. This colossal event was a single, continuous storm. An atmospheric river of destruction that defied simple categorization and left a scar on the landscape visible from space. This phenomenon has a name, a derecho. The word is Spanish for straight ahead, and it perfectly describes the storm's defining feature. Unlike tornadoes, which have rotating winds, a derecho produces a massive, long-lived wall of destructive straight-line winds. To be officially classified as a derecho, a storm must meet three strict scientific criteria. First, its path of wind damage must extend for more than 240 miles. Second, wind gusts along most of its length must exceed 58 miles per hour. And third, it must include several well-separated gusts of at least 75 miles per hour, the speed of a Category 1 hurricane. To understand a derecho, you must first understand its engine. It is born from a weather system known as a mesoscale convective system, or MCS. This isn't a single storm cloud. It's a sprawling, self-sustaining complex of thunderstorms, an organized army that can cover an entire state. The 2020 system was a particularly powerful example. It drew immense energy from the hot, humid summer air, organizing itself into a coherent line that focused all its power in one direction. It became less a collection of storms and more a single, unified entity. The process begins with a simple mechanism. Inside the towering clouds of the MCS, rain and hail fall toward the ground. As this precipitation descends, some of it evaporates, a process that dramatically cools the air around it. The sprawling mesoscale convective system provided the fuel. The advancing cold pool acted as its piston, relentlessly driving it forward, and the rear-inflow jet served as its turbine, converting atmospheric potential into raw kinetic fury. These were not separate events occurring by chance. They were the interlocking gears of a vast atmospheric machine, a self-perpetuating engine of wind that assembled itself over an entire continent, built for one purpose: to move straight ahead. This is the profound truth of the 2020 derecho. It was not an act of random chaos. It was an exhibition of atmospheric order, a highly structured system executing its terrifying purpose with flawless efficiency. Understanding its intricate mechanics does not diminish its power. Instead, it deepens our awe. It reveals the elegant, organized, and sometimes devastating architecture hidden in the sky, constantly at play right above our heads. This creates a dome of cold, dense air directly beneath the storm system. Because this air is heavier than the surrounding warm air, it sinks and spreads outward along the ground. This expanding bubble is known as a cold pool. This cold pool acts like a miniature cold front, a plow pushing forward. As it expands, it forces the warm, moist air in the storm's path upward. This upward lift creates new thunderstorms along the leading edge, continuously regenerating the system and driving it forward. But this forward motion alone doesn't explain the sheer violence of the 2020 storm. The cold pool explains how the system moves and sustains itself. It does not explain how it generates winds powerful enough to flatten millions of acres of crops and forests. That incredible velocity, the source of the hurricane-force winds, comes from a different, more powerful mechanism working deep within the storm's core. The storm wasn't just moving, it was generating an internal jet engine of destruction. As the storm's cold pool surges forward, it creates a crucial imbalance. The leading edge of the storm effectively outruns its own air supply. This leaves a region of lower pressure just behind the main line of thunderstorms. The storm creates a vacuum in its own wake. The atmosphere immediately works to correct this. To fill the low-pressure void, air from the mid-levels of the atmosphere, several miles up, begins to descend. It's pulled downward and forward. It accelerates as it falls toward the back of the storm. This powerful, descending current of air is the engine of the derecho. It's called the rear-inflow jet. This isn't just a breeze. It is a concentrated, high-speed river of wind diving from the sky, aimed directly at the back of the storm front. Imagine this jet of air as a massive atmospheric fire hose. It is pointed almost straight down toward the ground. When this high-velocity jet hits the surface, it has nowhere to go but to spread out horizontally, blasting forward with immense force. This is what produces the massive wall of destructive, non-rotating wind. It is not a cyclone's spin. It is a linear, sustained assault. The rear-inflow jet is the mechanism that transforms a cluster of strong storms into a long-lived, straight-line wind catastrophe. This entire atmospheric process reached its terrifying peak over a single city, Cedar Rapids, Iowa. Here, the abstract science became a brutal reality. The storm's internal engine, the rear-inflow jet, intensified dramatically as it approached the city. It slammed into the ground and produced measured wind gusts up to 140 miles per hour. That is the equivalent power of a Category 4 hurricane. This force was unleashed hundreds of miles from any ocean. But unlike a hurricane, which offers moments of calm as its bands pass, this was different. The Derecho delivered a relentless, sustained barrage of extreme wind that lasted for nearly an hour. It was a battering ram made of air, a force that didn't spin, it simply flattened everything in its path. The impact of this focused power was staggering. The 140-mile-per-hour winds flattened an estimated 14 million acres of crops across the state of Iowa alone. It was a scar on the landscape so vast, so complete, it was clearly visible from space. In Cedar Rapids, the storm destroyed an estimated 65% of the city's tree canopy. This wasn't just a weather event. It was a geological scale force, born from invisible physics in the sky, that reshaped an entire ecosystem and a human community in less than 60 minutes. The true cost of this atmospheric river is staggering. The 2020 Midwest Derecho became the single costliest thunderstorm event in United States history. Its total damages exceeded $11 billion. This wasn't just a storm. It was an economic catastrophe delivered by the sky. That immense financial toll highlights a terrifying truth. These widespread, fast-moving storms, while lesser known than hurricanes or tornadoes, can deliver a comparable level of devastation. The damage wasn't confined to one town. It was a sprawling wound across the entire agricultural heartland of a nation. This raises a critical question. Why are these events so hard to predict? Unlike a hurricane, which can be tracked for days as it churns across the ocean, a derecho is born from speed. The specific conditions that escalate a strong storm system into a catastrophic derecho can develop in mere hours. There is no long approach, only a sudden, violent arrival. Meteorologists can identify high-risk environments. They look for hot, humid air providing fuel, and strong upper-level winds to help organize the system. But predicting the exact location and moment a storm will reach that tipping point, the point where the rear-inflow jet takes over and accelerates it into a monster, remains an immense scientific challenge. The forecast models can show the potential. They can flag a day as dangerous. But they struggle to resolve the small-scale features that act as the trigger. A subtle shift in wind, a slight temperature change. These tiny variables can be the difference between a severe but manageable storm and a billion-dollar disaster that reshapes a landscape. Now, scientists are looking to the future, asking how a changing climate might affect these storms. The fundamental physics are clear. As global temperatures rise, the atmosphere can hold more moisture. More moisture means more available fuel for massive storm systems like the one that spawned the 2020 derecho. The connections are not simple. A warmer world might also change wind patterns that are crucial for a storm's organization. Scientists are actively researching whether a warmer, wetter climate will lead to more frequent or more intense derechos. The answer is locked in the complex interplay of atmospheric forces, a puzzle we are still trying to solve. The 2020 Derecho was unforgettable because it was a raw demonstration of organized atmospheric power. This wasn't random chaos. It was a highly structured, self-perpetuating system operating on a continental scale. It was a machine built of wind and water, moving with terrifying purpose. Understanding the science behind it, the cold pool, the rear-inflow jet, the delicate balance of atmospheric ingredients, doesn't diminish its power. It deepens our awe. It reveals the hidden, intricate, and sometimes devastating physics that govern the air we breathe and the sky above our heads. But the story of the Derecho doesn't end with the winds. On the ground, in the quiet that followed, another force emerged. It was the resilience of communities facing a landscape they no longer recognized, a testament to human adaptation in the face of atmospheric power. The ecological toll was staggering. Across Iowa, an estimated 10 million trees were damaged or destroyed. This wasn't just a loss of scenery. It was a sudden, violent restructuring of entire ecosystems, a reset button pressed on forests and wildlife habitats over a single afternoon. The impact went deeper than the surface. The immense force of the wind altered the very soil. It accelerated evaporation, stripping moisture from farmland already stressed by summer heat. This created cascading effects on local water cycles, a subtle but significant change written into the land itself. This raises a profound question for atmospheric scientists. Do events of this magnitude leave a kind of memory in the atmosphere? Could the sheer energy released by the 2020 Derecho have influenced weather patterns in the days or even weeks that followed? Answering that requires new tools. Scientists are now refining high-resolution models and using next-generation satellites. The goal is to see the subtle ingredients of a derecho coming together earlier. They are searching for the faint atmospheric signature that precedes the storm's violent birth. And this is not just a story about the American Midwest. The physics that power a derecho are universal. Similar long-lasting straight-line windstorms have been documented in Europe, Asia, and South America. They are a global expression of atmospheric mechanics, a powerful reminder that the same forces shape weather across the planet. Ultimately, these storms are a part of Earth's vast energy budget. They are violent, efficient mechanisms for moving heat and moisture. The atmosphere is always seeking equilibrium, and a derecho is one of its most dramatic tools for achieving that balance, albeit on a terrifyingly local scale. For millions, the 2020 event did more than topple buildings. It introduced a new word into their vocabulary and a new reality into their understanding of risk. The storm transformed a meteorological term into a lived, unforgettable experience, permanently changing how we view the summer sky. What these powerful storms truly reveal is the invisible architecture of our world. We see the rain and feel the wind. But the derecho makes us witness the underlying structures, the powerful river of a rear-inflow jet, the boundaries between air masses, the immense thermal energy waiting to be unleashed. It makes the unseen forces of our atmosphere visible. The sky, therefore, is not a passive ceiling above our world. It is a dynamic, churning ocean of energy, governed by immense and complex forces. The 2020 derecho was not an anomaly. It was a clear, powerful demonstration of the planet's hidden power, a story written in the wind.